Hi, in Joranalogue's Tech Thursday upload of this week, Joran talked about the hold feature on Filter 8, which adds, well, a lot of functionality to the filter that you, at least to my knowledge, cannot find on any other filter. This morning, as usual on a Friday the last couple of weeks, I had my go at a patch. So let's have a look at it. There isn't an awful lot that I can add to what Joran already explained. So really, if you are curious about how the hold input performs, just check out his video. I just want to show you this patch, and for this I have to unmute a synth, of course. What you're hearing right now is an output of Generate 3, this one here. And I'm using the first output of Filter 8 here as a pitch source. And to create this kind of fluid stepped random, well, it's completely not random, but it just appears to be. I used the hold feature on Filter 8, but let me turn it off so you can see and hear that Filter 8 is self-oscillating. So I turned up the resonance to achieve this. And it's doing so at audio rates. And let me remove the gate modulating the hold parameter here. Now if I flick this switch, you can see that the filter core tries to hold. Now at these high frequencies you can see it's not holding 100%. If I do this at LFO rates, the hold effect is, well, a lot more stable. But you can see and most definitely hear that there is some kind of well, very, very slow oscillation still going on. Now again, if we do this at audio rates, the remaining oscillation is much more noticeable, which doesn't bother me at all for this patch. This cable is routing a gate pattern into the hold input, and currently it's turned off, so the gate input is not active. But if I turn it on, you can see this happening. This gate pattern is actually the step output of step 8, which I'm clocking with an oscillator. But I'm using the step output because this produces very, very narrow or short triggers. And sometimes you can see one pop up here on the scope, but what I did is I inverted the short triggers coming from the step output of step 8. And I offsetted them, and what this results in is, well, like a pulse wave with an almost with a duty cycle of almost 100%. There's a steady 5 volt DC offset with very, very short dips in it. What this means is that I'm sending in long gates, and it's only when we have this dip in the voltage that I'm sending in here that the filter core is allowed to just oscillate. And because it's oscillating so very fast at audio rates, in that short time it travels to a completely different segment of its oscillation. And this gives us this kind of weird or unusual stepped gate pattern. Now if we play around with the frequency of the filter, we introduce more, well, pseudo randomness. And if I then start modulating the frequency of filter 8. The pattern becomes a little less predictable. Now I've taken another output of filter 8 here, just because, well, you can see that by using a completely different output here, the gate pattern is, well, really different, while it still follows the same timing. I used this bottom wave to modulate my filter. Well, I need to reintroduce it first. And well, let me just add the rest of the patch. I added an output of orbit 3, which is getting sequenced by step 8. And I've routed the output of my audio source, which is still just this generate 3, to an envelope and VCA combo. And let's of course add some percussion. Maybe first some effects, reverb, delay, and then some percussion.